Good morning everyone. Myself Akila. Today I am here to present about network topology. Introduction to network topology. Network topology refers to the physical or logical arrangements of devices and connections in a network. It also explains how different devices communicate with each other and how data flows between them. The choice of topology affects network performance, reliability, scalability, and maintenance cost. A good topology helps in better communication and reduces network failures. There are different types of network topology, mainly bus topology, star topology, ring topology, and mesh topology. Each topology has a different way of connecting devices. They differ in terms of reliability, maintenance cost, speed. Now I will explain each of them one by one. Bus topology is a type of network topology where all the devices share a single communication cable called bus. When a device sends the data, the signal travels through the main cable and to all the nodes. The advantage is that it is simple and requires less cabling cost. However, if the main cable fails, the entire network is being affected. There are also a lot of chances of collisions. Some of the real world examples are early Ethernets that are used in small offices and in schools. Star topology. In star topology, all the devices are connected to a central device called hub or switch. The central devices manage communications between the other devices which are connected. The main advantage is that it is easy to manage and troubleshooting. If one device connection fails, the other device continues working. However, if the central device stops working, the whole network can stop. Some of the real world examples are office LANs, school labs, home Wi-Fi's. Ring topology. In ring topology, all devices are connected in a closed loop. Data travels from one device to the next, usually using a token passing method. The advantage is that it provides predictable performance and controlled communication. The disadvantage is that failure of one link or device can affect the entire ring unless backup methods are used. Some of the real world examples are telecom and metropolitan fiber rings. Mesh topology. Each device is connected to multiple other devices. This creates multiple paths for data transfer, which makes the network highly reliable. The main advantage is that fault tolerance because even if one path fails, the another path can be used. The drawback is that it requires more cables and is expensive to implement. Some of the real world examples are internet backbone, military mesh network, wireless mesh deployments. Now, let us compare the topologies we have seen till now, that is bus, star, ring, and mesh topology. Bus topology is low in cost, poor in reliability and scalability, and moderate in maintenance. Star topology. Star topology is moderate in cost, good in reliability and scalability, and easy to maintain. Ring topology. Ring topology is moderate in cost, fair in reliability, and moderate in scalability, but very challengeable in maintenance. Mesh topology. Mesh topology is high in cost, excellent in reliability and scalability, but complex in maintenance. Scalability. Star and mesh scale well, bus degrades quickly under load. Real world applications of different types of topologies. Different topologies are used in different kinds of situations and environments. Bus topology. Bus topologies are commonly used in schools and campus networks as it is simple and inexpensive to deploy. Star topology. Star topologies are widely used today in offices and homes because all the devices are connected to a central switch or router, making management and troubleshooting easier. Ring topology. Ring topologies are preferred in telecom or metropolitan networks because where data can travel through multiple paths, improving reliability. Mesh topology. Mesh topologies are used in backbone and defense areas. It provides high redundancy. Even if one connection fails, the data can travel through another path. In this way, topologies differ from scalability, reliability, cost, etc. To conclude, topology is basically a physical or logical arrangements of devices and connections in a network. It plays a major role in determining network performance, reliability, scalability, and cost. We have also discussed about different types of topologies, their advantages, disadvantages, working principle, and the last but not the least, real world applications. While choosing a topology, organizations must consider some factors such as cost, scalability, network complexity, and redundancy. The recommended approach is to first assess the network requirements, then select the most suitable topology, and finally validate the design before deployment. Thank you.